Something.
Yeah, and then press it.
Ah, there you go.
To give you a summary of some of the work that I've been doing with Rutgers as part of this project.
You guys see that?
I've been working on Objective 2, which is essentially developing environmental recipes to condition daughter plants for optimizing field or greenhouse production. A little more specifically, the idea is to take a single crown plug plant developed from a runner tip, and from that, using various lighting treatments, create a multi-crowned tray plant. We can either keep that tray plant vegetative to be put into field plasticulture and then allow floral initiation to occur in the field. And with this option, what that would do is it would reduce the critical nature of planting date that's inherent to the plasticulture system. The second option would be to take that multi-crown tray plant and induce floral initiation with a change in lighting during propagation. You then have a multi-crown floral tray plant that you could use in either greenhouse production or perhaps even spring planted plasticulture with or without a hot tunnel. Now, my work has been focusing on determining if we can regulate plug development with lighting to create these types of plug plants. We know that crown branching, runner production, and inflorescence production in strawberry is controlled by the pigment phytochrome, and that it's the amount of phytochrome in the far red form, the active form, that remains at the end of the dark period, which regulates whether you see a response to photoperiod or not. We also know that red, far red, and blue light are the three wavelengths that primarily regulate phytochrome in a plant. And the timing of the exposure of plants to these colors is also important in what type of response you get. Whether you give them the exposure at the beginning of the dark period, the end of the dark period, or as a night interruption. There have been many studies that have looked at different colors of light given at different times and what the response strawberry plants have to these different treatments. However, one thing that this project allowed me to do was to do a thorough investigation of all possible combinations of these lights and timings. Because as far as I know, even though there are a tremendous number of papers out there on strawberry responses to photoperiod, there's never been a study that has looked at all possible combinations of the colors and the timings with a control. And this project was instrumental in having that work done, because it allowed me to set up the equipment that I needed to be able to do a study such as this. And pleased to say that one of the studies that I did evaluating the different timings and wavelengths was published in the International Journal of Plant Biology. Last November, it was published. This year, I've been working on a number of different experiments related to this project, but I'd like to really focus on the first one that I have listed here. I have an experiment where I essentially repeated the work that I published concerning Soraya in the publication I just showed you, looking at 22 different treatments and their effect on flowering, runnering, and branch crown production in Albion, Chandler, and Sweet Charlie. Albion's another long bay cultivar, and Chandler and Sweet Charlie are short bay cultivars. I've also done some work looking at flowering and runnering responses to the far red fraction. And far red fraction is just a relatively new metric for describing what lighting conditions plants have been exposed to provide the treatment effect that you've observed. And the far red fraction is, I think, a little bit more useful than simply just saying what type of light bulb you used in your different treatments. And I also was working on a study where I was looking at Sweet Charlie, Chandler, Albion, and Royal Royce responses to preconditioning treatments in a high tunnel setting. I'm going to focus primarily on the first study, primarily because of time restraint. And with that experiment, I had Albion, Chandler, and Sweet Charlie plug plants that I exposed to a 13-hour photo period at 150 micromoles at a fairly high temperature. The high temperature theoretically should prevent flower formation in both long and short day cultivars. And the high temperature was basically the result of having the plants in their grow tents, which I'll show you a photo in just a second, in a shaded greenhouse. They were treated for 6 weeks with 21 different lighting combinations and a control to give a total of 22 treatments. They were treated in these grow tents that were in the greenhouse. I had 24 of these grow tents. A sample of the plants were dissected after treatment to flower map them. Another sample were planted in a long day greenhouse to evaluate inflorescence production, runnering, and crown branching. Set were put out in the plasticulture system. Now, unfortunately, the plasticulture system didn't make it to complete because of this severe deer pressure we have at our Green Ridge site. The flower mapping procedure I used for this experiment was relatively simple, whereas I dissected the terminal meristem of each plug and gave it a rating of either 0 for vegetative or 4 for well-formed inflorescence. I then analyzed that data using an analysis of variance, and then mean separation using Dunnett's procedure. Now, Dunnett's procedure is a statistical technique that's very handy for comparing a number of different treatments to the control. And then you indicate the difference with either a plus sign or a negative sign. A plus sign would indicate that that treatment enhanced whatever it is that you're looking at compared to the control. And the negative sign would indicate that it inhibited the process that you're looking at when comparing it to the control. So, for example, here, the floral rating from the flower mapping with Albion indicates that there was a significant effect of both timing and wavelength on flower initiation. Red and far red given as a night interruption or far red as an end of dark period treatment significantly enhanced flower formation compared with control, which remained vegetative after 6 weeks of treatment. Blue as an end of the dark period treatment, red plus far red as an end of the dark period treatment, or red plus far red plus blue as a night interruption, all enhanced floral formation compared to the control. Now, I think the important thing to remember with flower mapping is that this is a snapshot of what those plugs look like after 6 weeks of treatment. To be of use, you have to be able to go from these flower mapping ratings to, did you see the response when you had it in a particular production system? For example, in this case, I had greenhouse data to look at. And here we're looking at the cumulative inflorescence production in a long day greenhouse after 12 weeks of forcing after treatment. Notice here that we do still see some wavelength and timing responses compared to the control in terms of enhancing flower production. For example, red or far red as a night interruption. In this case, also far red as the beginning of the dark period treatment, and then red, far red, and blue as a night interruption. So we got slightly different results when you looked at inflorescence production during forcing versus what we found with flowering. For example, here's both of those tables shown side by side. Notice that far red, given at the beginning of the dark period, had a floral rating of vegetative. However, after 12 weeks in a long day greenhouse, we see that we had at least one inflorescence per plant produced under those conditions. Now you might say, well, perhaps flower buds were formed under those 12 weeks of greenhouse production. I don't think that that's really the case, because if that were the case, the control plants, I think, would have formed flower buds, and you would have seen a much higher number rather than a 0.2 inflorescence per plant. So I think this is one of the weaknesses of flower mapping, is that you might not see flower bud initials with flower mapping. However, the process has started. Simply because the flowering process is a gradual process, beginning with induction in the leaves, ending up with production in whatever. And most likely that induction at the beginning of bugs, yet we see initiation under those conditions. So I think that is just indicating us some of the weaknesses or limitations, I should say, of flower mapping. So generally, takeaways from this work, I think, would be that flower mapping is useful for an instantaneous description of the floral status of strawberry. However, it doesn't necessarily predict what you might observe under production conditions. It also seems that in a broad general sense, that long day cultivars are more sensitive than short day cultivars to light treatment when it comes to especially flowering under different conditions. And a third thing that I think is a good takeaway from this work is that Dunnett's procedure is a very useful tool for comparing enhancement or inhibition of growth processes by treatments in strawberries. And that's really what we're trying to do. Do any of these lighting treatments enhance flowering or inhibit flowering? And this statistical technique is a very powerful technique to use to determine the answer to that question. I thank you all for listening this morning, and if you have any questions, I'd be glad to try to answer them. You could also email me questions if you have them later on, and you have my email address. Thanks a lot, and I hope you have a great meeting.